Define a wavefront using Huygens principle. Verify the law of reflection at a plane surface. Part B. In a single slit diffraction experiment, the width of the slit is made double the original width. How does this affect the size and intensity of the central diffraction band? Explain. See the first part of the question. Define wavefront. The wavefront may be defined as a surface of constant phase. Okay. Alternatively, we can define it as the wavefront is a loci of all points that are in the same phase. Okay. And this is the incident wave, and this is the reflected wave, and these are some of the notations. We will discuss this one now. Let speed of the wave in the medium by v. Let the time taken by the wave front to advance from point B to point C is 2. That is from point B to point C, this 2. Hence, BC is equal to V into tau. Let CE, C to E is represented the reflected wave front. This is the reflected wave front. Distance AE, distance A to E is nu into tau is equal to BC. Therefore, triangle AEC, AEC and triangle ABC, ABC are congruent. Therefore, triangle BAC, BAC is equal to triangle ECA. Okay, this is the verification of the law of reflection at a plane surfaces. In this way, we can verify it. Okay, next part B. In a single slit diffraction experiment, the width of the slit is made double the original width. How does this affect the size and intensity of the central diffraction band? Explain. Size of the central maxima reduces to half. Okay, because size of the central maxima, that is equal to 2 lambda d divided by a. That means intensity is increases. This is because of the amount of light entering the slit has increased and the area over which it falls decreases. Explain two advantages of a reflecting telescope over a refracting telescope. Some of the advantages of the reflecting telescope over the refracting telescopes are: first one is mechanical support is easier. Magnifying power is larger compared to the refracting telescope. Resolving power is also very large. Spherical aberration is reduced, free from chromatic aberration. These are some of the advantages of the reflecting telescope over refracting telescope. When a teeny circular obstacle is placed in the path of light from the distance source, a bright spot is seen at the center of the obstacle. Explain why. It's very simple. Because this is because of the diffraction of the light. Alternatively, we can say it is as light gets diffracted by the teeny circular obstacle and reaches the center of the shadow of the obstacle. Or we can say it as there is a maxima at the center of the obstacle in the diffraction pattern produced by it. Draw a ray diagram to show image formation when the concave mirror produces a real inverted and magnified image of the object. Obtain the mirror formula and write the expression for the linear magnification. Part B question. Okay. Part A. So this is the ray diagram. Show image formation when the concave mirror produces a real inverted and magnified image of the object. Okay. This is the concave mirror, and the outer line indicates the polished one, and this is the focal length. This is the points K, real, inverted and magnificent image of the object. Part B, obtain the mirror formula and write the expression for the linear magnification. Okay. Now, we will keep as this diagram as it is. Then we will have the equation. The above figure, triangle BAP and triangle delta B A dot and P. Okay. BAP. These two triangles are similar. Therefore, we can write a BA divided by B dash A dash, which is equal to PA divided by PA dash. Similarly, when you want to observe the triangle MNF, M, N and F, and triangle B dash A dash F, triangle B dash A dash and F, these two triangles are similar, then we can write MN divided by B dash A dash is equal to NF divided by FA dash. As MN is equal to BA, observe here, MN is equal to BA. This distance is the same, then NF is almost equal to PF. NF is almost equal to the PF, almost equal to the PF. Okay. Then FA dash is equal to PA dash minus PF. FA dash is equal to FA dash is equal to this total length F2A dash. This F2A dash is equal to PA dash minus PF. Okay. Therefore, equation 2. This is the equation 2, and equation 2 takes the following form of BA by B dash A dash is equal to PF divided by edge of FA dash. It is a PA dash minus PF. Then using the equation number 1 and 3, we can write PA divided by PA dash is equal to PF divided by PA dash minus PF. For the given figures, as per the sign conversions, PA is equal to minus U, PA is equal to minus U, PA dash is equal to minus V, PF is equal to minus F, then minus U by minus V is equal to minus F divided by minus V minus of minus F. Then U by V is equal to F divided by V minus F. UV minus UF is equal to VF. Dividing each term by UVF, we get 1 upon F minus 1 upon V is equal to 1 upon U. 1 upon F is equal to 1 upon V plus 1 upon U. Linear magnification is equal to minus V by U. Okay, this is the alternative. M is equal to Hi by H naught. This is the expression for the linear magnification.